lines. Does the slope ever change? Different lines, slopes can change, but how about the same line?
No, it doesn't.
Nope, it doesn't change. So for a line, first of all, we can say constant slope. Yeah, different lines have different slopes for sure. But on one given line, wherever you are, the incline is going to be the exact same. It doesn't change. That's not necessarily true in nature. Like sometimes you have steeper inclines or less steep inclines, like if you're going on a hike or something, going through different hills, etc. One mountain can have lots of different inclines. It's not as pretty as you did like in elementary pictures, right? Like, yay, that's exactly, no, that's not very realistic for mountains. But lines have constant slopes, constant inclines. And what you guys already wrote down is m is the common way of talking about slope. We can say delta y over delta x. We can say y2 minus y1 over x2 minus x1. But this is assuming that you have 2 points. Use x1, well, I almost went to x2. x1, y1 would be 1 point, and then x2, y2 would be another point. And so then we can just say, subtract the y, subtract the x's, slope done. But what if we're not measuring a slope or a line with 2 points, but instead with its incline? Why do I keep on saying incline? Inclination. You guys know it's an English word, right? If you're inclined to do something, you have an inclination towards. It's kind of like you're leaning towards something, or you have a natural bent to choose a certain way, right? If you have a natural incline to something. I'm inclined to say, sometimes adults say that. Inclination in math is basically just like its tilt, its angle, how steep it is. So we're talking about specifically angles. And if you guys want to underline really quickly, we're always talking about positive angles. So if we have some sort of, if we find a negative angle, we're going to have to add to make it positive. If we have some sort of negative angle, we're going to have to add to make it positive. And not just add, but I'll give a little hint. We're going to have to add one. Ooh, good idea, but actually no, we're going to add 180. And you'll see why in a second. If we have a negative angle, we're going to add 180 to make it a positive angle. Because when we're talking about lines, lines go on forever. We actually don't care whether we're talking about well, for instance, a first quadrant angle or a fourth quadrant. I should say first quadrant or third quadrant or second quadrant or second quadrant, fourth quadrant. It's okay. I'll show you down here with the lines. But down here, here's some examples of inclinations. Okay? The incline of this guy is 0. Why? Yeah, there's no incline. There's no slope. I mean, literally, the slope is 0. So I guess you could ski that and you'd survive, right? But there's no steepness. There's no hill. There's no incline. But what about this guy's incline? It would be pi over 2, or it would be 90 degrees. That's the kind that you die on. Don't we already know that the slope of this guy is 0? Like cross-country skiing, this guy is undefined, because you better be able to fly, right? I'll go ahead and write out the whole word, just because it was a little confusing. Guys, what's the slope going to be of this dude? If you have, no, the theta is the angle. What's the slope going to be? It's not 0. It's not DNE. What sign is it going to have? Some positive number, because I'm going uphill. But this one's going downhill, so therefore this one's going to be a negative. Because whenever we read or read graphs in math, we move left to right. So we're going uphill, going downhill. So positive slope, negative slope is going to go with an acute angle, an acute inclination, or an obtuse angle, an obtuse inclination. So this is just starting to get us along the same lines of somehow angles are related to slopes. Because, okay, that made sense, but, oh, that doesn't. I mean, those aren't the same. Why would that be a positive with an acute and a negative with an obtuse? Is there anything in trigonometry? That would be 0 at 0, undefined at 90, positive in the first and third quadrants, and negative in the second and fourth quadrants. It's positive in the first and third quadrants. I thought sine and cosine always alternated. What trig function is 0 at 0, undefined at 90, positive in the first and third quadrants, negative in the second and fourth quadrants? Tangent. All students take, right? Oh yeah, positive over a positive and a negative over a negative, and then one of each and one of each. Only tangent is the guy who will be the same value 180 degrees apart. And you might be thinking like, wait a minute, what are you talking about? This isn't first and third quadrants. Well, no, but if I was to put this around the origin, it would be. The inclination is a first quadrant angle, or if I were to go the other direction 180 away, it would be the third quadrant. The inclination is a second degree angle. If I were to go the other way, a fourth degree angle. All of this just kind of leads us up to it. It's not the reason why, but it's just hints saying, oh, maybe it does make sense that the slope of a line would be the tangent of the inclination. The slope of a line. So guys, lines aren't new, just inclination is new. We haven't really talked about the incline before. We have talked about how steep something like a vector is, but we haven't really talked about how steep like just a line is. So inclination, new way of talking about a line. And if they give us an inclination of a line, we have a new way of finding slope where we don't just use rise over run and we don't just use 2 points. Now we can actually use this thing called an incline. However, as you guys were saying a second ago, if you're given lines, do we like seeing a line in ax plus by equals c, aka standard form? Do we like that at all? No. We don't like standard form because standard form is messy. So when I asked you about slope, I wanted you to go to rise over run, but you went to, this is the equation of a line I like best. And what equation was that? That's a good one for calculus, but the one the majority of the general population likes best is y equals mx plus b. Because the meaning is easiest in most of our brains as far as what it means or how to use it. So if they give it to, if they give us lines like this, what do you think I'm going to ask you to do first? Convert it. Get it to something that your brain processes well. So can you get to the point where you understand this is going to be y equals x minus 2? How would I rearrange? Step by step, how would I get there? You could subtract the x to give steps. You could subtract the x, right? So negative y would equal 2 minus x. Divide everything by a negative. So y equals negative 2 plus x, which should be rewritten as x minus 2. Some of you guys would have had to very carefully go through those steps, and you might have made some mistakes along the way. But in my brain, I think it's easier for mental math. I think that's a really hard way to do mental math. It's not bad as far as algebra. Yeah, you can subtract. Yeah, you can subtract. Yeah, you can say negative y is equal to 2 minus x. Yeah, you can divide by a negative 1. Dividing everybody by a negative 1 would be negative 2 plus x. Ew, that's gross. I could rewrite it. Does it work? Yeah. But mental math, wouldn't it be easier to add the y? And then subtract the 2? Yeah. Y equals x minus 2. Just a mental math trick. But either way, is this now in a form that I like? Yes. Yeah. This one would be a little bit, I don't know, maybe easier, maybe harder, because you just subtract the 2x and divide the 3. But then you would also have to divide the 6 by the 3. Some of you might need to do some algebra to get there. But either way, with a few steps, we can get y equals mx plus b exactly what you guys like, or the form that you guys prefer, which is totally cool. But guys, what was the question? It wasn't get it into slope-intercept. Okay, so for letter A, if I have y equals x minus 2, my question to get the inclination is, who is the m? 1. And if m equals 1, can't I say 1 equals tangent of theta? Ooh. Does anybody notice what showed up at the very beginning of my notes? You guys going to time me? Tell me when it goes on the 6. That'll be easy. When it gets to the 30-second mark. Ready? Remember, sine goes first, then cosine, then tangent. We have 0, 30, 45. Maybe you guys are thinking about what this would be in radians. I'm talking while going 0, 1, 2, 3. Oops, no, that's in tangent. 3, 2, 1, all over 2 with the square root, with the square root, 2 with the 2 with the square root. I know, I'm slowing down. Square root of 3 over 3, 1 square root of 3, undefined. Okay. So when I sing 1, 2, 3, 3, 2, 1, all over 2, square root of 3 over 3, 1 square root of 3. Is it the whole thing? No. But is it the most important, most easily confused parts? Yeah. Yes. Why am I showing this to you? Because we need to figure out when tangent is 1. And I'm going to keep on singing square root of 3 over 3, 1 square root of 3. Because if it is one of those 3 values, if it is one of these, I can go backwards to the answers very quickly, and so should you. When is tangent 1? Easy, 45. Or pi over 4. True? Now, answers in the back of the book. Does this say, get it for me in radians? Get it for me in degrees? No. So I guess it could be either. Theta is equal to 45 or pi over 4. And how are you supposed to know that? Unit circle. Okay. If you want to think about it, why is it 1 at 45? Because not everyone uses the cheater chart, because only, oh, that's awkward. Only at 45 is sine, square root of 2 over 2, and cosine, square root of 2 over 2. So when you do tangent equals sine over cosine, they reduce to be 1. Now, that wasn't bad because of unit circle. But what's going on when we get to b? Y is equal to negative 2 thirds x plus 2. What's my m? So negative 2 thirds is a tangent? Square root of 3 over 3, 1 square root of 3. Meh. It's not there. So why do I have you with your calculators out? Because not all of them are going to be unit circles. You allowed to use. What math would you do to go back? Don't you have to undo the tan to get to the theta? I know that Joe's saying second tangent, which is good, but I need to know the math. That's just the calculator buttons to push. How do you undo tangent? No, I can't divide by tan. Inverse tangent. Inverse undoes. So look at second tan in your calculator. Isn't that tangent to the negative 1? And what does tangent to the negative 1 indicate? Tangent inverse. If I do tan inverse to both sides, tan inverse of tan, like a square root to a squared, like an e to an ln, will undo. But I can't just do it on one side. It's lopsided. Tangent inverse. Theta is equal to tangent inverse of. Now, if you guys want to double check me and make sure I'm right, you could do tangent inverse of 1. You could have done that in your calculator. But if you were in radian mode, I don't think you would have seen a nice, pretty pi over 4 answer. It would have been a nasty decimal, 0.7 something, 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 something. But if it was in degree mode, it would be a nice 45. But down here, tangent inverse of negative 2 thirds, either radians or degrees, probably won't be perfect, so give me some decimals. What are you guys getting? Negative 33 point? Now, why am I not boxing this answer? Like I'm not doing it on purpose. Why am I not boxing this answer? I never put on my closed-toed shoes that are waiting in my car. Oops. A little bit illegal right now. I left my Toms in my car last night. Question. Why can't I box that answer?
It's a negative degree.
Oh. Okay, we just wrote a note. We just wrote a note about it. Right? Inclinations have to be positive. So if it's negative, add 180, but why? I don't get it. If I was to graph this line, intercept of 2, going down 2 over 3, right? Question. Would negative 33 be one way to describe this line? Yeah. Negative 33.690, one way.
Oh, but you can
But here's,
the other way.
yeah, exactly.
Right to left.
So one way is to look down. The other way is to look up. So even though this is negative 33.690, I don't want the negative angle. Inclination must be positive. So therefore, that's one way of getting to the line. I need to go the other way. And guys, if I'm down here, how do I go the other direction? I have to make a 180 turn, right? So no stress. My inclination, theta, yeah, it's going to end up equaling 146.310. Does that make sense? A silly way of thinking about it. Silly, 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 silly. What if this is the ground? And what if this is the mountain? Right? If this is the ground, this is the mountain. You're standing on it. If I asked you how steep the mountain is, what would make more sense? You measuring this angle to the mountain, or you digging a hole in the ground until you meet the other side of the mountain and then measuring? Yeah, the first one. So we're thinking of what makes more natural sense. A positive angle, in some ways, makes more natural sense. Okay. But what if they give us the inclination instead? What if they give us the, oh, no stress, we have a formula. M equals tangent of, plug it in, plug it in. So sometimes you're plugging in the M and getting the theta, but sometimes you're plugging in the theta and getting the M. And the nice thing is, isn't 2 pi over 3, isn't that a unit circle value? Isn't that 60 degrees in the second quadrant? So tangent is going to be a negative number, and 60 degrees is the third one. Square root of 3 over 3, 1 square root of 3. It's the third one. Which makes sense because it's a downhill line that goes through pi over 3. So I need a negative slope. Slopes can be negative, just the inclinations can't. Slopes can be negative, just the inclinations can't. So how about this guy? Find the inclination given 2 points on a line. Oh. It's not as easy. I can't just plug in an M, but what can I do? Can't I find my M and then plug it in? So they didn't give me the M outright, but I can go ahead and do y2 minus y1 over x2 minus x1. I can find my M to then plug in square root of 3 over 3, 1 square root of 3, which is at a 60-degree angle. I found my M to plug into my M spot of my formula. And it was a nice unit circle-y one. Guys, we still have 2 minutes. What's going on? Right? 55? Cool. Because we have one more formula, and it's kind of important. I'm not going to make you find the formula, but I am going to make you write down the formula, or else it's going to be very sad. All those little deer in the headlight looks. Whoa, we just thought you'd end 2 minutes early. You know me better than that. To find an angle between two lines, we could find one inclination and another inclination, and then go talking about which in between we're supposed to find. Ugh, that's confusing. So I'm not going to make you discover, I'm actually even going to take away this page. I'm not going to make you discover how to find it. Instead, I'm just going to say, you know what, there's this cool formula. And the cool formula says, if you need to find the angle, trying to find theta, you start by saying, okay, but I know about tangent of theta. Now, once again, if they give it to you in standard form, you're going to want to rewrite it. It'll just make life a little bit easier. But you're going to have two different slopes because you're going to have two different lines, and you're working with them together at the same time. So what you're going to have to do is call one slope M1, the other slope M2, and then the name of the game is, can you plug and chug? The nice thing is once you have all the given information, you're allowed to use your calculator because it might not be a unit circle problem anyway. Is there in our calculator, cool kids? Pause. You stole a couple seconds from me. I'll steal them from you. Is there a cool fraction bar in your calculator? Could you type this whole thing in? But how do you get theta? Get rid of who's on the outside? So you guys can go, as soon as you see, I'm going to take tangent inverse of this whole shabam. You see it? Yep. And then we're going to plug and chug it to our calculators and get our final answer. Degrees or radians, I don't think it matters unless the book says so. Corrections in my there or box by the end of the day. Bye, cool kids. Good job. That was the entire section 10.1 minus one example and one discovery that we don't need.